Welcome to our 341 Final Project, where we will be taking you on a tour of JavaScript and how we can incorporate it with SAGE2. My name is Tobin Hwang.
And I'm Matt Carter.
So our program will simulate Conway's game of life using JavaScript. Now the game of life, which I'm sure most of you are familiar with, for those who are not, player interacts with game of life by creating some type of initial configuration. It is essentially a zero-player game. After the initial configuration, the program will evolve and the user will stand back basically and observe it. As you can see right now on this screen, we have Google's version of Game of Life that they have as part of their web browser. So a little history about it. It was developed by a British mathematician, John Horton Conway, in 1970. So we've constructed a program using JavaScript, and we will be taking a deeper dive into the code as we go through the presentation. So just before that, I do want to talk about why did Conway develop this, okay? So Conway wanted to simplify a problem presented in the 1940s by mathematician John von Neumann. Now Neumann tried to build a hypothetical machine that could build copies of itself, and he did succeed in doing it, but it contained a very complicated set of rules. And what his goal was to pave new ways for cellular automata. So anyways, Conway was able to take Neumann's hypothetical machine and create a set of rules much simpler. Mac, would you mind scrolling over to the set of rules that we have written down? Yeah, so there's 4 specific rules. Any live cell with less than 2 neighbors will die. Any live cell with 2 or 3 live neighbors will live. Any live cell with more than 3 live neighbors will die. And then for any dead cell that exists with exactly 3 live neighbors will come back to life. So we can run our simulation really quick. Now we're gonna take a deeper dive into our program, but just to give you an idea what it looks like, we're gonna go ahead and step through our program. So we'll go ahead and click. And you can see that's the first iteration. Go ahead and click again. And you can see that the model completed. We can run it one more time to show different variations of it. And you can see this one extends a little further. So that's basically the program that we've created. But I want to talk a little bit more about the technology behind the program. So specifically about JavaScript. Okay, so JavaScript is a high-level, dynamic, untyped, and interpreted programming language. So in keeping with the spirit of HTML and CSS, it is one of the 3 essential technologies for internet programming. It's a multi-paradigm language that supports object-oriented programming, imperative programming, and functional programming. So we want to make sure that people understand that JavaScript should not be misconstrued with Java. Both have very different semantics. So a little fun fact about JavaScript. It was developed in just 10 days, about 20 years ago, by Brendan Eich.
SAGE2 is developed here at UIC in conjunction with Lava Labs in Hawaii. Work was started in 2014, and it now has stable release versions. SAGE2 is a scalable group environment that takes advantage of JavaScript and its universal portability. It runs on Node.js, which is a server application suite written in JavaScript. Our code is written to work with SAGE2, and this allows our software to be displayed across multiple screens in massive resolutions. All right, so now I'm going to explain our code a little bit and walk through it. So here is a copy left, copyright, which allows anyone to copy our source code, claim it as their own, modify it, sell it, whatever. Just make our code open source. We had to use HTML to display it in a web browser. This is also up online, so any of you can go and mess with it. It'll work on your phone since it's written in JavaScript. Here we have the canvas element, which is where everything is drawn to. It's inside of the body of the document. And you'll notice here on resize, we call a function on the body, so just take note of that. We'll get to a resize function later. So this is the beginning of our script. We set up some global variables, which are important to the state of the game. We grab some very important values from our window and make sure our canvas is the full size. We go through and set up all of our initial values, including how big our square size is. This determines roughly how many squares we have on the screen. As we're going through, we initialize our board. We set up a little thing to know if it's working or not. So this should look moderately like the pattern that you saw earlier in the video, where I started clicking around on our application. And then we get to a function call here. This update function is just beginning this recursive call function, which draws the screen at 60 frames per second. And here we get to my step function, and the step function is what actually runs the game code. So every step is a new state. And right here we've included a very nice explanation of the rules of the game of life, which is distributed with this code.
Yeah, right. So when I had introduced the game earlier, this is a more in-depth description of how the game is supposed to work. So now taking a look at this part of the code, this is kind of where the game logic is written. So let's go ahead and take a look at some of this code. So the first thing is, notice that we also created a little description down here to show what each section is doing. So what this code is doing is checking all the squares around that X. Okay, so, and it checks that C where we have this arbitrary C value, basically like a placeholder for a neighbor. So we're checking all the neighbors to X, and then we want to make sure that every time that we do have a neighbor next to X, that we are going ahead and increasing the neighbor count, which will be used later. So each incident where we do have a valid neighbor next to X, as you can see for every position, we're updating neighbors. So we're just going to come down to the code right here, and we can see that now we're going to check, so now this is where we're going to compute the new state of the game, right? So now every single time, like I said in the beginning, you create like some initial condition, and then the code's going to run, and it's always going to keep updating its state depending on what neighbor is next to it. So every single time it's going to go ahead and redraw that state. So this is where it updates the array, and this is where it actually creates that new state array. And then down here, we go ahead and basically draw the new state. As you can see, we make live cells become green. The cells that were previously live in the last state are now gray, and then the dead states are now black. And then we go ahead and display all those items.
Continuing on from there, we have some additional functions that were, pretty necessary for us. So we have this click function. This is an event listener. So basically a callback function on a click. When the browser receives a click, specifically when this canvas object receives a click, it's going to call this function, and this code will run. So let me step you through that. We get the X and Y position of our mouse, like where our cursor is. We grab the element of the canvas, then we check it relative to the canvas, so we get the actual X and Y position on the screen. As we step through this, we get the amount of cells in the X and Y direction, and then we check if we're inside a cell. This is checking if we're out of the bounds of our map, which would be a bad thing. And if we are inside the bounds, then we compute what cell we're in, and we change it correspondingly. If it's alive, we make it dead. If it's dead, we make it alive. And then we draw the updated change. Here we have a function that I was talking about earlier, which is our resize function. And if you resize the window, the way our game code is written is it completely throws out everything it knows about the old size of the array, and it creates some new arrays, and so it resizes it completely, so it gives you more slots to run your simulation. So this is basically all the same code in the beginning. We have to reinitialize our array. We have to regrab the height. We have to reset the max spaces. Then we go through and copy over our temporary array, which might have some data from the previous state of the game. So you're going to save, if you make your screen bigger, you're going to have some previous state data. So that'll be, so you won't lose everything. But if you make it smaller, you might lose some of that state data. And then this is just going to, again, draw the squares just like Toby was saying above. And then this just strokes the image, so this just puts it on the screen. All right, so I have this stop and start function, which allow the animation to stop and start. We saw a variable being checked, which was this stop start variable, and that's really it. You guys can check out the game of life that we've written at www.whaleblubber.net/S then AGE.
I'd like to thank everyone for checking out this video. So if you have any questions, feel free to reach out to Mac and I, and we'll catch you guys in class. Thanks.